All right, so now we're going to learn some basic properties that we will need to know for the rest of the year. But these are things that you already should have learned from previous years in math. That's the commutative property and the associative property. Now, there's the commutative property of addition and multiplication. Basically, the commutative property is just saying that addition can be flipped around. The order can be flipped around. A plus B is the same thing as B plus A. For example, I'll show you. If I do a 2 plus a 3, that's a 5. That's the same thing if I do a 3 plus a 2. That's also a 5. Same thing with multiplication. If I do a 2 times a 3, that's a 6. And if I flip the order around, if I do a 3 times a 2, that's also a 6. Now, it only works for addition and multiplication. We cannot use this for subtraction. I'm going to show you right now. A 2 minus a 3 does not equal a 3 minus a 2, because a 2 minus a 3 gives you a negative 1, and a 3 minus a 2 gives you a positive 1. A negative 1 does not equal positive 1. So there's no commutative property for subtraction. And same with division. I'm going to use even numbers here. A 4 divided by a 2 does not equal a 2 divided by a 4, because a 4 divided by a 2 is a 2, and that doesn't equal a 2 divided by a 4, which is a 1/2. So there is no commutative property for subtraction and division. We cannot change the order around when we are dealing with subtraction or division. For multiplication and addition, it does not matter. Now, the associative property is the grouping of multiple terms. So typically you're going to have 3 things that you're adding or multiplying. Sometimes you might have 4 things that you're adding or multiplying, and it doesn't matter what order you do those things in. So, for example, if I do the 2 plus 3 plus 4, then if I do the 2 plus 3 first, that's a 5, and a 5 plus a 4 is a 9. That is the same thing as if I did the 3 plus the 4 first, because a 3 plus a 4 is a 7, and if I add that to the 2, I still get a 9. So it doesn't matter if I do the 2 plus 3 first, or if I do the 3 plus 4 first. So if I group the 2 plus 3, and I group the 3 plus 4 differently, you still get the same answer. Same with multiplication. If I did a 2 times a 3 times a 4, if I did the 2 times 3 first, that's a 6, and then times a 4 would give you a 24. It doesn't matter if I did the 2 times the 3 first, or if I did the 3 times the 4 first. So if I did 3 times 4, that's a 12, and a 12 times that 2 is a 24. So I still get the same answer no matter if the grouping is different. Typically, to identify the associative property, you will have parentheses, but sometimes the commutative property will have parentheses too, so you need to be careful. Commutative property is when we actually flip the entire order of your 2 things around, whereas associative property is when we group 2 different things together first. So we'll get some practice with that in the following problems. So numbers 1 through 7 say to identify the property that's being used in each of these examples. Well, in number 1, I'm doing a 5 plus a 19, and then I switch the entire order around to get a 19 plus a 5. So when we switch the whole order of your 2 things that you're adding together, that's the commutative property. And we need to be specific here. We're not just going to say commutative property. We're specifically going to say that this is the commutative property of addition. Oops. I'm okay with you guys abbreviating. So if you want to say commutative property and then afterwards just put in parentheses a plus sign to show that it's of addition, then I'm okay with that. In fact, I'm going to be doing that from here on out. If you want to just actually spell out of addition or multiplication, I'm okay with that as well. So in number 2, we have a 1 times a 2 times a 3, and we have a 1 times a 2 times a 3. The order stayed the same, but what happened was the first one we group the 1 and the 2 together, and the second one we grouped the 2 and 3 together. So the grouping is different, which this means that this is the associative property, and it was of multiplication, so I'm going to put multiplication in parentheses. All right, next one. In the first one, I have a 17 plus an 82 plus a 4. In the second one, I also have a 17 plus an 82 plus a 4. So the order was not flipped, but what happened was in the first one, I grouped my 17 plus 82 first, and in the second one, I grouped my 82 plus 4 first. So that's the associative property, and since there's plus signs, this is the associative property of addition. Again, order does not matter, grouping does not matter when it's coming to addition and multiplication. So the left side is equaling the right side in each of these. Same with number 4, the left side equals the right side. Now in number 4, we have 5 plus a 4 plus a 9, and on the other side I have a 9 plus a 4 plus a 5. The order changed. What happened was the 5 and the 9 flipped around. So since the order changed around, that is the commutative property. Since there are since there are addition symbols, that means that this was the commutative property of multiplication, or of addition. I keep saying multiplication, it's addition. All right, moving on to the next one here. I have an 18a plus a 17b. And the second one, I have a 17b plus an 18a. What happened was the 18a and the 17b flipped around. So that is commutative properties. Since the two things, this one's a little tricky, there are multiplication symbols technically in this. However, since the two things flipped around a plus sign, then that's the commutative property of addition. All right, next one. I have a 5ab on the left. I have a 5ba on the right. What happened was the a and the b flipped around. Now, since there's no symbols here, there's technically multiplication symbols between the 5, the a, and the b. So this is, since the order flipped around between two terms, this is commutative property, and this would be multiplication. All right, we have the last one here. I have an x plus a 7. There's technically a multiplication symbol between the x plus the 7 and the 2x plus 1. And then I have a 2x plus a 1 times, because when there's no operation in between two sets of parentheses, that means that's a multiplication symbol in between them, times an x plus a 7. Now, what happened was the order flipped. These two things that I'm circling in blue flipped around the multiplication symbol. So since the order flipped around the multiplication symbol, it was order that flipped, that's commutative property. And since it flipped around the multiplication symbol, that's the commutative property of multiplication. All right, this one was a little bit challenging because we do see addition signs in there, but it's not the commutative property of addition because we're not flipping around an addition symbol, we're flipping around a multiplication symbol. Also, this one was a little tricky because we do see parentheses, so you might have thought, oh, this must be associative property. I did tell you up front that sometimes commutative property could have parentheses, so we're not just looking for the parentheses and calling that the associative property. We need to make sure we really understand what's going on with the actual problem. All right, so numbers 8 through 11, it says to demonstrate the property that is being asked of you in the following examples. So in this first example, we want to demonstrate the associative property of addition. Associative property is grouping. Right now, I have the grouping of the 4 plus the 2. So instead of grouping the 4 plus the 2, what if I grouped the 2 plus the 7? That is the associative property. I changed the grouping, but I didn't change the actual value of this expression. You still get the same value regardless of the grouping being flipped or being changed here. Number 9, we're doing the commutative property of multiplication. So here I have a 7 times an a, because remember when there's no symbol in between that 7 and a, that's really multiplication there. So I want to flip the order. There's multiple ways you can write this. You can write this as an a times a 7 like this, and you could write it as an a times a 7 like this. I will not allow you to write it as an a times a 7 like this, though, because that actually means something different in algebra. So we're not going to be writing the number after the a without putting an operation in between. And technically in the second one here, the parentheses means that this is going to be multiplied together. All right. Moving on to number 10, we want to demonstrate the commutative property of addition. So there's many ways that we can do this because all we're doing is switching the order in commutative property. So maybe we want to switch the order of the 8 and the 1. So maybe we want to do a 1 plus a 3 plus an 8. That's one way that you could demonstrate this. Or maybe you wanted to flip the 3 and the 1 around. So maybe you want to do an 8 plus a 1 plus a 3. That's another way you can demonstrate the commutative property here. Or maybe you wanted to switch the 8 and the 3 around. So you want to do a 3 plus an 8 plus a 1. That's another way you can demonstrate the commutative property here. It's up to you on this one. There were multiple different ways to demonstrate that. And then on number 11, we're doing the associative property of multiplication. So right now the 8 and the 3 are grouped. To demonstrate the associative property, we would group the 4 and the 8 together. Notice I'm not changing the order of the 4, the 8, and the 3. I'm just changing which ones are being grouped. All right, and that's it for the lesson or the review of the commutative and associative properties.